Hello everybody, good morning or good afternoon, whichever class you might be in. Here are your bell ringers for the day, so please have the substitute pause the video and you can work through these problems. Alright, so looking at these problems, solve the equation. We've done plenty of these before, so remember the best way to get rid of the fractions here, we want to get rid of those. We're going to multiply everything by a denominator, a common denominator, between 2, 4, and 3. That would be 12, okay? We're going to multiply everything by 12, and that should take care of our fractions, okay? So when we multiply the first one by 12, 7 over 2, that 2 is going to cross cancel with the 12 to turn it into a 6, so it'll be 6 times 7, which is 42, and we have to carry that x with us. The 4 will cross cancel with the 12 to get us to a 3. So 3 times 3 is 9. And then this 3 will cross cancel with that 12, turning it into a 4. 4 times 2 is 8, and we have the x. And then there's nothing that cross cancels with that 5, so 12 times 5 is 60. Okay? From there, we should be able to start to move things around. So let's put the x's on the left side. And then let's put the numbers on the right side. So I'm moving the 8x to the left by subtraction and moving the 9 to the right by subtraction as well, because they're both positive. Okay, so over here on the left, we're going to have 34x, and then on the right, we're going to have a negative 69, and then we can divide those two numbers. So divide both by 34. Alright, so both by 34, we get x equals negative 69 over 34, which so we have to see if we can reduce a little bit, which I don't think we can, because 69 is an odd number, 34 is an even number, so nothing will come out of those. So that's our solution for that one. It's kind of an ugly number to check. Second one, solve and graph the inequality. So we only see x's in here. That means it's just going to be on a number line. So it's best to move your x's to the left. If you don't do that, remember you're going to have to flip it around in the end so you don't mess it up when you're reading. Okay, so moving the x's to the left, we're going to have a negative 2x on the left, and moving the numbers or the constants to the right. Subtract that 3, we're going to have 2x is less than negative 9. Divide both sides by negative 2, okay, which is going to flip our inequality around. So either way, we're just going to have to kind of flip that inequality. But remember, you always read it from the variable. So x is less than 9 over 2. So we can draw our 0, negative 1, positive 1, 2, 3, 4. 9 over 2 is 4.5. So I'm going to be over here. It's going to be an open circle because we don't have that equal to, and then it's going to be pointed towards the left because it's x is greater than 9/2, so we got to make sure that we flip that sign when we divide by that negative. So let's put our 0, and then let's go by 2's here, because 9 over 2 is actually 4.5. So negative 2, negative 4, positive 2, positive 4, and we're at 4.5. So I'm going to put a 6 over here, so 4.5 will probably be about there. It's going to be open circle and pointed to the right because it's greater than. Okay, so it'll look like that. So for the third problem down here, find an equation of the line that has a slope of 1/2 and goes through the point 3, 4. All right, so we have a few different ways we can do this. You always want to write out that slope so you have it somewhere, and then we have the point 3, 4. So if we have a point and a slope, then more than likely we're going to just be using point slope form. And this just says find the equation. It doesn't specify which form. All right, so let's do point slope form. Y minus y1 equals m, which is 1/2, times x minus x1. Okay, so from there, that's good enough if we want point slope form. If we want to go slope intercept, we're going to have to distribute that 1/2 and move the 4 over. So y minus 4 equals 1/2 x minus 3 over 2, or 3/2. Add 4 to both sides. Okay, so this is really like 1.5 or 1.5. If you want to think of it as a mixed number, we're going to make it an improper fraction when we're done. So y equals 1/2 x. So when we do these two here, that's going to be 2.5, which will be 5/2. So plus 5/2. And you can double check that with your calculator. Right, so 4 minus 1.5, that would be 2.5, and it'll be a positive, so it should be 5/2. Okay, so there are your bell ringers. The next thing we're going to look at are a few homework questions. Okay, so 31, I actually wrote that out for you the other day. That was the one with the t-shirts and the hats. So we'll look at how we actually get our answer for that one. But just to remind you guys how we set that one up, okay? So we are buying t-shirts and hats. Our cost for each one of those, so it's $6 our cost and $4 our cost. So this is the t-shirts and this is the hats. So you could use T and H if you wanted to. But then when we sell them for $10 a piece and $7 a piece, okay? When we bought them, we paid $2,000 for our cost, and when we sold them all, we made $33.75. Okay, so let's see how much we actually paid, or how many of them we sold. So remember, X is t-shirts, H is hats. Okay, so when you're solving problems like these, you can do it with substitution or elimination, which we talked about last week. But if we are using, I would say use elimination here would probably be the best one, because substitution you're going to end up with fractions and it's going to kind of cause you a little bit of a headache. So we look at the front numbers here, those two, the 6 and the 10, and we try to get those to be the same number but opposite value. So between 6 and 10, if you're thinking maybe like a common denominator, what number would 6 and 10 both go into? So greatest common factor. 6 and 10 both go into 30. So I'm going to take this bottom one times a 3 and the top one times a 5. Now the 3 and the 5, that number doesn't have to be the same, but after I multiply, the number in front of the x should be the same. So 5 times 6 will get me 30, 3 times 10 will get me a 30. Let's make this one a negative. Okay, so that way they're going to cancel out. And we're going to rewrite those down below. So 30x plus 20y equals 10,000. Right, 5 times 2 is 10, and we got 3 zeros behind it. The next one, so I'm going to rewrite that down here. So 30 is negative 30x minus 21y is going to be equal to, and that one you might need your calculator for. So that one is going to be a negative 10,125. And then we're going to add those together. Okay, just straight up add those equations together. These ones are going to cancel out. That was the point of doing that. We'll get a negative 1y or negative y, and then we'll get negative 125 over here. Negatives are going to cancel out, so we have 125 for y, okay, which the y we said is our hats. So we have 125 hats. All right, so we want to figure out how many t-shirts we sold, which we could have canceled out the y in order to figure that out, but we canceled out the x, which was our t-shirt. So now we have to take the 125 and plug it back into the equation. I like to use the numbers that are smaller. That first equation has smaller numbers, so let's go ahead and plug it in and solve. So 6x plus 4 times 125 equals 2,000. Okay, so 4 times 125, that gives me 500, and we're going to have to go ahead and move that 500 over to the other side. All right, and we'll have 6x equals 1,500, and then divide by 6, and we get 250, so x equals 250. So we sold 250 hats. Okay, so that is a way we can use our linear systems to solve. All right, so we're going to look at 65, 66, and 73 here quick. I probably won't work through them completely, but I'll get you started on all of them. So 65 and 66 are just basic linear system problems, and you can solve with substitution or elimination. So 65, working like we have been, let's try to get rid of the number in front between an 8 and a 6. The smallest number, greatest common factor, would be 24. All right, so with the bottom one, to get a 24, we're going to take it times a 4. And then the top one, to get a 24, we're going to take it times a 3. Let's make the bottom one the negative one. Doesn't matter which way you do it, but I will multiply those through here, and then you can finish them out. All right, so we'll have 24r minus 15t equals, so 60 times 3, that's a negative 180. And then down here, negative 4 times 6 is a negative 24r minus 12t equals, so 18 times 4, that's 1836, 72. And then you just add those two equations together. Those will cancel out. And you'll solve for t. Plug that back into one of the equations to get the r. All right. Number 66, very similar to the one above. All right, except we won't have to multiply by a negative because we have that here already. All right, so the top one, we're going to take that times 10 and 4. We're going to get a 20 is probably the best number. Take that times a 2. Take this one times a 5. All right, so 20t plus 8b equals 26. And then we'll have negative 20t minus 35b equals 55. The t's are going to cancel out, and then you should be able to solve for a v. Plug that back into your equation up above. Okay. 73 was a word problem with vans. We have van A, and van A has 2 adults, 5 students. Cost of that van is $77. That would be how we set up the equation for van A. And then van B, you got 2 adults, 7 students, and it costs $95. Okay, so that's the equation for van B. So when we set those up, probably the hard part is just setting up the equation, and then we go ahead and solve. From here, it's pretty quick because we have 2x and 2x, so all you got to do is multiply one of these by a negative, and then you'll go ahead and you can get an answer right away. So 5 minus 7 is negative 2y, and then 77 minus 95, that's going to be 20, nope, it'll be 18, so negative 18, so y equals 9. Those were my students, so that's why I had the A and the S there above. My students cost $9 a piece, okay? And then we can take that 9, plug it into one of the equations. Let's just say we're going to plug it into here. Oops. Plug that 9 into here. So we'll have 2x plus 45 equals 77. We're going to try to find the adult cost of the ticket. So that's x would be the adults. Minus 45 on both of those. You get 2x equals 77 minus 45 is going to be 28. Nope. Yeah, 28. And divide both sides by 2. We get x equals 16. So it's $16 for the adults, $9 for the students. Homework problems, you can finish those up quick, and then we will get started on the lesson. All right, so the lesson is 1.7 and 1.8, solving systems of linear inequalities. That's just graphing more than one inequality on a graph. So we'll take that one kind of quick, and then 1.8 is optimization with linear programming. We'll take that one a little bit slower so we can understand that one better. All right, so let's jump into it. So a little bit of review for graphing inequalities. We did these already. We've done these. So you graph the line, make sure you check if it's solid or dotted. And then number 2, we didn't really do that. I talked to you guys a couple times, told you what you need to do. I'll do it once or twice here to check to make sure we did it correctly. You're going to choose a point not on the line and then test, which means plug it in to see if it works. Okay? If that point does work, then we should have shading there. So if that point does not work, you should not have shading where that point is. All right, so let's jump into graphing 2 right away, because I think we know how to graph one of these already, so let's just graph two on the same graph. So you're going to want to have graph paper for today. All of our notes actually are going to be graphs, so make sure you get some graph paper before we get started. It is on the filing cabinet if you did not get any to start with. Okay, so let's go ahead and graph these two. They're already set up for us, so that's going to make it kind of nice. So the first one, y is greater than negative 2x minus 5. So we look at the y-intercept of negative 5, and then we're going to start there. And our slope is negative 2, so that's negative 2 over 1. So we go down 2, right 1, down 2, right 1, and then we can kind of continue our pattern the other way, so that way we can see how our line is going to go. So it's greater than, so that means we're going to be shading above, and it's going to be a dashed line. So we're going to be shading on this side of the line. That's the first one. Second one, y is greater than or equal to x plus 3. Okay, so we're going to start at 3, and then our slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1, kind of like that. Okay. And then this one is a solid line, as straight as I can draw that. That's a solid line, and it's greater than, so we're shading above. All right, so what you're really looking for here is where your shading overlaps. And if we look at that, it should be pretty easy to determine or to say that this is where our shading overlaps, that kind of triangular shape up there. Okay, so I'll show you how to do your little checkpoint, your test point here to make sure you did it correct. So you want to find a point that is inside that double shaded region. And if I'm looking here, let's just say we go negative 2, 2, kind of right in there, negative 2, 2, okay? Let's check that point. So you're going to plug that point in for the x and the y of these two inequalities to see if it works. So the first one here will have 2 is greater than negative 2 times 2 minus 5. So on the right hand side here, we'll have negative 4 minus 5, which is negative 9. Is 2 greater than that? Yes, that one works. So negative 2, 2 works in the first one. Try the second equation. 2 greater than or equal to negative 2 plus 3. So we'll get a 1 over here. So yeah, that works again. So that point is correct, that double shading is correct, okay? So that's just the way you check your point to see if you did it correctly. Next one, go ahead and try this equation here. So please pause the video a little bit, and then I'll kind of pick up where you guys left off or however far you're into the problem, and we'll finish it from there. Okay, so starting out, we needed to solve this one for y. Okay, that's the best way that I've kind of shown you guys how to graph these things. So we're going to move that 2x over. So we'll have 3y is less than or equal to negative 2x plus 6. And then we're going to have to divide everything by 3. All right, so that equation is y is less than or equal to negative 2/3 x plus 6 over 3. That's a 2. And then we can go ahead and graph our equations here. So the first one, we're starting up at 2. So right here, and we're going negative 2/3 as my slope. Right there. Okay, so let's see if we can use our line tool here. And that's going to be a solid line. Okay, so here we go. Solid line through those points. We are less than or equal to, so that's good. We're shading down. Let's do our next one. So we have negative 2/3 x plus 4. So starting at 4. And we're going negative 2/3. So again, down 2, right 3, down 2, right 3. And then we end up with that line. So let's use, this one is going to be a dashed line. Okay, so we missed it a little bit. Let's adjust that. And we are shading above. All right, so for linear systems, in order to have a solution, we have to have where the shading overlaps. So if you're looking at this one, does the shading ever overlap? Well, no, because the top line and the bottom line are parallel. We're shading above that one and below that one, so there's never going to be any overlapping. So in this case, you don't have a solution. All right, which can happen. You can have parallel lines, just like in linear systems. They won't have any solutions because they're never going to touch, and in this case, the shading will never overlap. Let's take care of this one, and then we'll take a break, and we'll finish up with our 1.8. All right, so you guys haven't done anything like this one before. We had it in a lesson one day, but I kind of skipped over it just for time's sake. We have done the top one before, so let's do this one quick. So remember if it's a y equals or a less or an x equals, excuse me, if that's going to be a horizontal or vertical line, you think about which axis it's going to hit. So if I drew a line, this one is only going to hit the y-axis. So I'm going to hit the y-axis at 3. So I start at 3, horizontal line, and it's a dashed line. Okay, and then we're shading less than, so we're shading down from that line. Now for this second equation, this is an absolute value graph. Okay, we know that we see the absolute value brackets. So you think of value like this. And the V has arrows on it because this graph is going to look like a giant V on the screen here. So in order to graph these, there's a trick, there's a standard form of this, which we'll get to eventually, but I'm just going to show you guys how to do it with an XY chart starting out, okay? So draw yourself an XY chart off to the side of your graph somewhere so you can see that. And if we have anything inside the absolute value brackets, that's really what's going to help us figure out where to start on our XY chart. We can do our generic points, but sometimes you're going to see that it doesn't give you enough information. So since there is a 4 in there, you are always going to think opposite of that number. So if I have plus 4, then that means negative 4 is going to be where I start in my XY chart. And that's going to be right in the middle. Okay? And then we pick points around that. That's the way these work out right now. You can look inside there. That'll always tell you where to start. Okay, so then we pick points around that, which are going to be negative 5, negative 6, negative 3, negative 2. That's the middle one. Okay, then go ahead and just plug those into that equation and see what you get. All right, so what I mean, we're going to take these values, and I know I got arrows kind of going all over the place here. Take that negative 2, plug it in for the x. So negative 2 plus 4. Positive 2. Negative 3 plus 4, positive 1. Negative 4 plus 4, 0. Negative 5 plus 4 is negative 1, but we have our absolute value bracket, so that's just going to make that a positive 1, and then you'll see we get that. So it should be somewhat of a repeating pattern. So negative 4, 1, 2, 3, 4, negative 4, 0. Negative 3, 1, negative 2, 2. Negative 5, 1, negative 6, 2, and then that is how we draw our graph. So just kind of connect the dots here, and you can see that it's the shape of a V, like that. And we have to follow our inequality sign here. It says greater than, so since its y is greater than, I'm going to shade inside of that or above my absolute value graph. And then this right here, that overlapping, is our solution. And again, you could pick a point inside there and check it, and it should work. Okay? So the XY chart is the way to go whenever you see graphing an absolute value equation. So hopefully that makes sense. Okay, so you could have 3 of them at once. Just graph all 3 like normal, and it'll make like a triangular shape like on this one, but it'll be 3 lines rather than an absolute value and a line. All right, so here we're on to our break. So we're going to do a walk the beach today. Since we can go outside for our brain breaks, we are right by the outside door. Make sure when we go outside, you're 6 feet apart. You can have your masks off if you are 6 feet apart, and prop the door open so you don't get stuck outside. Also, don't forget to beep the office. We got to ring the office before we go out. So on your walk, talk about how has your year been going this far. So it's been good, been bad, maybe talk about a little of both. And then the second thing to talk about, what is one wish you have for this school year? What is something that you wish would happen this school year that would just make your year? Okay, so go ahead, take your break, and come back in, and we'll start 1.8. We're going to finish up here with 1.8. We'll do a couple examples. So this is going to be a new topic for you guys. It's called optimization with linear programming. So linear programming, linear is lines. So we're going to have lines that represent specific scenarios, going to graph those lines, and then that's going to give us some information that will help us optimize a situation. Okay? So your vocab words here, we have linear programming and feasible region. So linear programming is just when we find a maximum or minimum value for a given constraint, which will be the lines that we graph. And then the second part is really more important. It's called the feasible region, okay? So the feasible region is the shape that is formed by the lines, and really more specifically the vertices or vertex points of the solution set graphed by the inequalities. So we want to look at the shape we make, and we want to look at the points of intersection of all of the lines. Okay, so when you open your book or when you look up here, I suppose, the problems look kind of big and ugly. Okay, and if you didn't get those written down, you can pause the video or go back. But these are really what the problems look like. Okay, so let's read through this one. There's a lot of extra stuff up here that we don't need as long as we know what we're looking for. So graph the following system of inequalities. Name the coordinates of the vertices of the feasible region. Find the maximum and minimum values of the function f of x comma y equals 3x minus 2y for this region. Okay? Sounds kind of ugly. So starting out, you see this thing and you're like, oh man, functions, I remember those. Function notation, that's the f of x stuff. Now it's f of x comma y. You don't need that until the end. Okay, so put it in a box and put it away. You don't need it until the end of the problem. You're not trying to graph that. You really can't graph that because it's got 4 different variables or 4 different things going on in there. Okay, so what we do want to do, start by graphing those. We can do that. Okay, and then I'll show you where we use the stuff in the box in a minute. So x is less than 5, less than or equal to 5. So we hit the x-axis at 5, right there, vertical line. Okay, and it's less than, so we're shading to the left. I'll draw a little squiggle like that so I know I'm on the left side of that line. Y is less than or equal to 4. Hits the y-axis right at 4. Less than, so I'm going down. Now we can kind of see some overlapping stuff going on. Then the last one here, let's rewrite that. So we have a y equals, so y is greater than or equal to negative x plus 2. So we start at 2, and we go down 1 over 1, down 1 over 1, down 1 over 1 to get that slope. And this is a solid line as well, okay? So right there. So when you're graphing these, you want to be careful, maybe get a ruler. You want to draw your lines as straight as possible if you are not drawing your dots, because we need to see where they hit. We need to see the vertices. If your vertices are off a little bit, then it's not going to be a very good graph. Okay, so I have one there, there, and there. Okay, so those 3 points will create my feasible region. And if I wanted to shade it with this other line, it's going to be above, and we'll have that shaded area is our feasible region. Okay, that triangle. So now we got our graph done. We have our feasible region. Now it's time to use this guy, because we don't know a maximum or minimum yet. We got our graph, we got our feasible region, we don't know a maximum or minimum yet. So when we do that, I make a little table. You don't have to. I would recommend it for organizational purposes on the first couple. My first column is going to be where I put my points of my feasible region. My second column is going to be where my work goes. And my third column is going to be the value that I obtain after I plug in the points. Okay, so let's write down our coordinates of the vertices. So right here, that one is 5, comma, negative 3. this one, 5, 4. And then that one, -2, 4. So now we want to plug in the x and the y into this equation here, and that's going to give us the values that we might want. Okay? So 3 times 5 minus 2 times -3. I'm going to do my work on this first one so you can kind of see what's going on. That gets me to a 15. That gets me to, so it's -2, -3, +6. So that's a 21. All right, hopefully you guys see how that works out. So the next point, 3 times 5 is 15, minus 2 times 4 is 8, and then that's going to get us to a 7. And then the last one, 3 times -2 is -6, minus 2 times 4 is going to give us an 8, so it's -14. So you look here in this column for the highest and the smallest number. So the smallest number here, that's our minimum. Biggest number here, that's the maximum. And that's it. Okay? So it takes quite a bit of steps to get through here. So just kind of repeat the steps here. Graph my inequalities. Pay attention to where my vertices are when I graph them. Then I take those vertices, plug them into this equation, and find the biggest and smallest numbers. That is how we do these in a nutshell. Okay, those 3 steps. They sound pretty simple, but it just takes a little bit of work. Okay? So, we're going to do one of these on the next slide. I'm going to leave it. You're going to pause the video and try to work through it on your own. If you were paying attention to this video intensely, which everybody does, you should know what to do. Okay? So, please pause the video here, have the students work through this, and then we'll check our solution in about 3 to 5 minutes. All right, so remember, right there, put it in the box, throw it away for the time being. And then we graph our inequalities here. So x is less than 4. We hit 4 on the x, going to the left. Y is less than or equal to 5. We hit 5 on the y. Okay, I might move that up a little bit. Come on, smartboard. I might move that up a little bit here. Right there. And then we graph our line here. So this is going to be y is greater than or equal to -x plus 6. So I start at, I actually have this line a little bit too high. Okay, we start at 6 for this one. We're going down 1 over 1, down 1 over 1, like so. Okay, 1, 2, 3, 4. Oh my gosh. So we start at 6 for this one. Okay, 1, 2, 3, 4, 5, 6, and we go down 1 over 1, right there, and that's a solid line shaded above. Okay, so you see that my lines aren't the best, but I drew those little dots out. That's going to help me find my vertices. So I have one there, there, and there. Those are the points that we're using to plug into our equation. Oops. Okay. So we have that one that we boxed at the beginning. And then we have our value that we're looking for. And let's write our points down. So we have 4, 2. And then we have 4, 5. And then we have 1, 5. Okay, so we plug those in. So this is going in for the x, that's going in for the y. So 4 times 4 is 16, minus 3 times 2 is 6. We get a value of 10. So the next one, 4 times 4 is 16, minus 3 times 5, which is 15. We get a value of 1. Plugging in the last one, we got 4 times 1 is 4. Minus 3 times 5, negative 15, so that gets it to a negative 11. So we got our maximum and min. Maximum right there, minimum right there. Okay, So that is how we do linear programming when we're just given equations and say find the maximum and minimum. It's pretty simple. It just takes a lot of work and you have to remember your steps. So again, graph the inequalities, find the vertices, plug them into my starting or my other equation, find the maximum and minimum value. Okay. Now on your homework there's going to be some problems that are word problems. This comes from your textbook. It kind of gives you steps to doing linear programming when we're working with word problems. Okay? The word problems are kind of big. They look like that. You'd have to read that and kind of pull out all the pieces. Okay? Now, you can always do these with optimization and linear programming. However, there are ways you can do it without. Okay? So don't think you have to make a graph with these. You do have to make a graph for the ones that just give you straight up equations. The word problems, not so much, okay? So I have this here. You can read through this quick if you want to. I'll have the video in Google Classroom for you to check it out again. But I'll show you the equations that you would use this, or you would use this word problem to create, okay? So we have an equation for mowing, an equation for pruning, an equation for both mowing and pruning. So the M stands for mowing hours, P stands for pruning hours, okay? And then there's another equation for pruning. So you'd be reading through this equation, trying to create something like that, and you could graph this one, and this one, find your vertices, plugging them into that one to find your best option, okay? So try the word problems. We'll look at them when I come back. But that is your homework for the lesson, okay? So give it a shot. Send me some emails if you have questions. Thank you.